Welcome to the Unit 2, Quiz Number 2 recording. If you need some more time between questions, please pause the recording. And if you have any questions, please let me know. Question number 1. How does an ion differ from an electrically neutral atom? There are a different number of protons compared to a neutral atom. There are a different number of electrons in an ion compared to a neutral atom. There are a different number of neutrons in an ion compared to a neutral atom. I'm going to read that one more time. Question number 1. How does an ion differ from an electrically neutral atom? There are a different number of protons in an ion compared to a neutral atom. There are a different number of electrons in an ion compared to a neutral atom. There are a different number of neutrons in an ion compared to a neutral atom. Question number 2. All ions and isotopes of an atom share the same atomic number, mass number, charge. Question 3. According to Bohr's model of the atom, in which orbitals do electrons have the least energy? Outermost orbitals, innermost orbitals, middle orbitals. Question 4. If an electron loses energy, what might happen to it? It will never change location. It may drop to a lower energy level. It may move to a higher energy level. Question 5 is matching. Want to match each suborbital to the number of electrons it can hold. We have the s orbital, the p orbital, and the d orbital, holding 2 electrons, 6 electrons, 10 electrons. Question 6. Put the following orbitals into the correct order energetically from lowest energy to highest energy. We have 3d, 1s, 2s, 3p. Question 7. From the list below, identify the only electron configuration that follows all the rules for filling orbital diagrams and writing configurations. 1s2, 2s1, 2p4, 3s2, 3p5. 1s2, 2s1, 3s2, 2p4, 3p5. 1s2, 2s2, 2p6, 3s2, 3p5. Question 8. Consult the periodic table. An electrically neutral atom has the following electron configuration: 1s2, 2s2, 2p6, 3s2. What is the name of this atom? Magnesium, aluminum, sodium. Question 9. Choose the best description of what's wrong with the following electron configuration for an electrically neutral atom of sulfur, atomic number 16. 1s1, 2s2, 2p5, 3s2, 3p6. The total number of electrons in the configuration does not equal 16, the atomic number of sulfur. There are low energy orbitals which have not been filled to hold the maximum number of electrons. The configuration is incorrect for both of these reasons. Question 10. An atom that has satisfied the octet rule will have which of the following valence electron configurations? A full s orbital, a full p orbital, both a full s orbital and a full p orbital. Question 11. Refer to the correctly filled orbital diagram for aluminum below to help you answer this question. Indicate how a neutral atom of aluminum, atomic number 13, will ionize. Let's see if I could go up a little bit so you could see the whole thing. It will gain 5 electrons. It will lose 3 electrons. It will gain 2 electrons. Let's move up one more time. Maybe I can make this a little bit smaller so you could see the whole thing. There we go. So question 11, refer to the correctly filled orbital diagram for aluminum below to help you answer this question. Indicate how a neutral atom of aluminum, atomic number 13, will ionize. It will gain 5 electrons. It will lose 3 electrons. It will gain 2 electrons. Question 12. When a neutral atom of bromine ionizes, it gains 1 electron. Choose which of the following symbols and terms most accurately communicates this change. Bromine -1, anion. Bromine -1, cation. Bromine +1, anion. Question 13. Which of the following symbols represents a cation? Neon, Ne, Na+1, F-1. Question 14. How many protons are in the oxygen -2 ion? 2, 8, 10. Question 15. How many total electrons are in the oxygen -2 ion? 2, 8, 10. Question 16. Which of the following is an example of an atom following the octet rule? A nitrogen atom that has 5 valence electrons gains 3 more to become nitride, N-3. A noble gas loses an electron to become a cation. A neutral atom exists in nature with 3 stable isotopes. Question 17. Erin took notes on her reading assignment about electron configurations and Aufbau diagrams. She made the diagram below in her notes with the plan to ask her teacher if the textbook had an error with the way the diagram was filled out. Before class, she shows you her notes. What might be a statement you make in response to Aaron's notes? According to the Aufbau principle, electrons fill orbitals with lower energies before filling higher energy level orbitals. You agree with Aaron that there must be an error in the textbook because it is not correct to ever skip an orbital when filling orbital diagrams. None of these are reasonable statements you would share with Aaron. Question 18. Which of the following electron configurations, notations, is correct for both a neon and a fluoride ion? 1s2, 2s2, 2p6, 1s2, 2s2, 3s2, 2p3, 1s2, 2s2, 2p6, 3s2. Question 19. Refer to the image below. Select the statement that best describes it. This is the Rutherford model of the atom, where electron orbitals resemble energy levels. This is the Bohr model of the atom, where an electron in the d orbital is higher energy than an electron in the lowest energy a orbital. Just like planets in the solar system, electrons cannot move among the orbitals from A to B, B to C, C to D, etc. I'm going to read that one more time. It looks like there's a typo right there. Just like the planets in our solar system, electrons cannot move among orbitals from A to B, B to C, C to D, etc. This is the first open-ended question. Question 20. The atomic number for magnesium is 12. Part A, in its neutral state, how many electrons are in an atom of magnesium? Part B, write the electron configuration, long version, not shortened, for a neutral atom of magnesium. Part C, how many valence electrons are in this neutral atom of magnesium? Part D, where are these valence electrons? Identify the orbital in which they reside. And Part E, explain why a neutral atom of magnesium becomes a cation. Again, you should pause the recording here so you have some time to answer. I'm going to move to the next one. Question 21 is also an open-ended question. Refer to the electron configuration and orbital diagram for sulfur below. We have the configuration here of 1s2, 2s2, 2p6, 3s2, 3p4. We also have the Aufbau diagram filled out for sulfur as well. Describe at least two ways the electrons in the 3p suborbital are different from those in the 2s orbital. Right? And then finally, the last question is optional. It will not hurt you if you try it and get it wrong. You do not have to try it. It is bonus, 5 points if you get it correct. Think about the terms valence electron, noble gas configuration, ionization, and octet rule. Write a short paragraph, 3 sentences minimum, that includes all 4 of those terms and any relationships between the terms. That's the last question on the quiz. If you have any questions again, please let me know, and good luck.